By watching today's Swarf and Chips, you're going to find out what sliding head machines are, what they can do, and how they can make your business more profitable.
Sliding head machines are becoming more prevalent in machine shops. They have bigger capacity in terms of diameter, bigger capacity in terms of lights out running. With multi-axis and driven tooling, they can make some really complex components. And it's not just all about big batch runs, but where did they all begin?
Lathes were first invented around 1300 BC in Egypt and Mycenaean Greece, but this was more about turning wood and stone. Fast forward a couple of hundred years, if not thousands, and you had the Industrial Revolution, where lathes were known as a mother of machine tools. The collet itself was patented in 1870, but the game changer was in Vienna, Switzerland in 1872 to 1873. A watchmaker, Jacob Schweizer, had the novel idea of sliding the part along the longitudinal axis of the lathe instead of moving the tool post down the part as traditional lathes do. Further, he envisaged the part would be supported in a powered turning headstock that moved the part through a guiding bushing, thus keeping it fully supported during the machining process. Here we have a little clip. Obviously not the original, but here's a modern sliding headstock. And then you have the guide bush. The actual guide bush itself is the brass looking piece. It's in the housing, and you can see the bar coming through that housing, hence the sliding headstock and sliding machine. With this new design, turning tools could then perform their necessary machining operations in very close proximity to the supporting collet, which provided the rigidity required, as per this image here. So you've got the headstock, guide bush and the tool right next to the guide bush. This ingenious take on the traditional turning lathe was originally known as a plate machine, referring to the original design of all the components being assembled on a steel or cast iron plate. They then adopted the Swiss moniker when the process was taken outside of Switzerland. By the mid-1880s, these machines were being mass produced by Nicholas Juncker of Juncker & C out of Moutier, Switzerland, which was and remains the watchmaking capital of the world. Later versions incorporated cams to automate the motion process for repeated manufacturing. After all, they were watchmakers. Today, this company is part of Tornos SA, a premier manufacturer of sliding headstock machinery, and although their designs have changed over the years and CNC controllers incorporated in their use, the core principle of a sliding headstock has not changed. There you go, moving backwards and forwards, lovely. Anyway, in the 1960s, they became even more popular. The 70s, they went to CNC. So here's a number of the more modern machines. Obviously, these are from the 70s. And then in the 80s, making even more complex components in industries such as the semiconductor and electronics markets. Then the 1990s, more sophisticated components such as medical and aerospace. A great example is this component here, an aerospace part. So there you have it, a potted history of the plate, Swiss type sliding head machines.
Welcome to this month's Swarf Talk, and on the set joining myself is Paul Jones.
Hello, good afternoon.
And Colin Griffiths.
Hello, Lindsay. Thanks for having
Who
me.
knows, oh yeah, an absolute pleasure. And you know a lot about sliding head machines, don't
I know a lot more now, let's just say that. But was I starting from a low base?
He's learnt a lot of very low base. We all know that. Right, okay, so it's going to be a busy show. So let's talk about why. Why would you use a slider? So let's set the scene. What I want to do is have a quick talk through sliders, but from one end literally to the other. But first, let's dispel a myth. Are they all about large batch runs?
That is a myth. I think these days, the way the machines are designed, built, the way the control systems are set up, they're a lot easier to set than what people think, and we've got a lot of users doing multiple setups on a daily basis. So they're making, really small batches, 25s, 30s, 50s off, maybe something like that. So it's very application specific.
For me to be profitable and invest in a slider, I've got to be doing big batch runs.
No, not anymore. That's long gone, those days. Basically, with the software that we have on board the machines and the way the machines are now easy to set up, that myth's gone because our setup times are minimised.
Wow. So
therefore, the volumes can come down accordingly.
So even 50 offs, 100 offs?
Yeah, I've actually got companies that are now only doing 10 offs at a time.
I mean, it can be anything from a batch of 100 plus. I think last year when we were heavily involved in a medical product that was at an embryonic stage, we were in the thousands per week sort of category of a very intricate design. We can develop a product in a small volume to get the design off the ground or to help a customer at a design rationale point of view.
Okay, so sliders have become more sophisticated, faster and more powerful. And whilst they are perfect for the big batch runs, we've learned already, smaller runs are now cost effective. So now let's talk about the actual machine. Let's start with the feeder or the loader. And not only that, we need to cover the difference.
Right, a loader as a rule, basically what we're doing is just pushing the bar on an end. Okay, so all we're doing is pushing it into the machine to a set value and retracting. We don't actually pull the part back, and it's not gripped by the actual push rod. It's just a pushing mechanism.
Simple definition is a bar loader, which is the industry refers to, would be a short magazine bar feed, which simply does load the bar, but it doesn't support the bar during the manufacturing process. Whereas a bar feed, such as this one here, would support a 3 metre length bar, traditionally 3 metre, outside the confines of the headstock machine. So the bar feed is in connection with the bar and supporting the bar.
And the bar is actually spinning
within the confines of the bar feed.
Okay,
whereas on a short magazine type bar loader, it simply pushes it and loads it back.
just loading.
Absolutely, yeah.
Okay. I mean, I've asked a lot of people, what's the difference between a loader and a feeder? And they're like, don't really know. Essentially, loader, just going into the machine, and that's it. The feeder is integral, so the bar is running with it. You're going to get a lot longer. I mean, some of these guys reference 6 metre long bar feeds. Absolutely huge.
And the longer
Really
the bar feed, though, the less remnant that you're going to have. So if
No, that's completely wrong, Paul.
Is it really? Yeah.
No, you're going to get less remnant when you're going guidebush, non-guidebush. We'll talk about that later. And also with a loader. So you generally with a feeder, you're going to get longer remnant.
Yeah, but what I mean is that if you have a shorter bar magazine or shorter bars, and you machine, say 15 parts out of that bar, you might be left with a piece that long, which is essentially dead because you can't use it because it's not maybe long enough for the next part. Whereas if you have a 6 metre bar,
less pieces of remnant is what you're saying.
Yeah.
Well, that's true, but I'm going to say application specific because we've got a great example at Dugard on their Hanwha machine where they've got a small slider, they've taken the guidebush out, they've put a small feeder on it, and they're running so small length of bar, lots of remnant, but it's just because the application is perfect for that
But
job.
it's why you would normally see much bigger bar feeds on
Yep.
sliding head lathes as opposed to the short ones because they're there to keep going, aren't they?
Yeah. So you've got up to 6 metres essentially, but also the diameter, which ties in with the next video.
Well, in our range, we can do bar stock from 0.8 millimetres up to 42 millimetre stock. It doesn't have to be ground stock. Yeah, they've got what we call pilgrim separators on, so they lift the material down the rack one by one until it gets into the channel, and the differences on those really small bar feeder is it's got a different clutch mechanism on there as well, so we've got an air clutch as well as a mechanical clutch, so it allows you to feed really thin walled material very precisely into the lathe.
So that's your loading mechanism, if I can say that. 0.8 millimetre of a bar, which is tiny, but that's where these sliders came from.
Controlling bar like that as well, because can you imagine how flexible it is?
Yeah, so that's slightly different for such small bar, but these will go up to 80 millimetre, which is a huge chunk of bar. I mean, with these guns, not a problem lifting it.
Not a chance.
Absolutely. Say 80 mil though, but sliders generally up to about 45 mil. Now the next thing though is you've got these feeders. It's not just about one bar at say 30 mil, 40 mil. You then need to change the channels over. So let's have a look at what's going on there. Okay, and then I'm looking here. You've got your channels, which are holding the bar. As an example, this one I'm looking at, I'm making an assumption it's 10 mil.
Yes.
What sort of variation can you have a bar for that size channel?
We could go down to around about 3 mil on that channel.
Okay.
Okay.
So about 7 mil.
Yeah. All you got to do is make sure we don't get too much gap between the bar and the side of the channels, because then we can create vibration, which will then go into the part on the machine.
But with this one, we don't need to do any of that.
Okay, so slightly different technology.
Through the HMI screen.
Yep.
And the bar feed will then be programmed by the operator.
Yep.
No guide channel sets need changing. The only thing that needs to be changed is the collet on the front of the push rod to suit the bar.
So there you have it, different technology on your bar feed. It's not loaded, let's hasten to add. So, but lengths, diameters, as we've already alluded to, but also bars come in different shapes. So that ties in with another video. Well, take a guess. Name some profiles.
Oh, hexagon, octagon,
Octagon, wow.
round,
Yeah.
square,
Yeah.
Pentagon.
rectangle.
I'll tell you
Rhombus.
what, let's have a look at the
It's a
videos.
building, isn't it? It's a pentagon of building.
On the front of the push.
Well, we can do hexagon bar, weird shapes. We've actually had customers who've had some extrusions made up recently, which we've managed to feed through and load automatically overnight as well without any problems. So the options become endless again. You know, D-shaped bars, anything rectangle, square, we can load
Anything
it.
you think of.
Yeah.
See, off camera there, Lindsay just said V-shape.
V?
And I don't want to stand on Colin Thompson. I'm Colin, but he's Colin Thompson. He said exclusions. I think it's extrusions. But hey, Colin, sorry about that. Mate. But essentially, any profile, you've got to have the collets, etc. But again, this is what we're alluding to in this show. The only limit on these machines is your imagination.
Well, I found when I've been out to companies, it's just when people have learned and they see a part and you go, how would you make that? And they think milling. And then they've said, no, I made that on my sliding head.
Exactly. And some of this is, we've done a job here which is milled only on our slider.
Yeah.
We'll come to that later.
I've seen that a lot.
And Les, you're going to have a nightmare here because we're going to talk about quality of bar. Well, you won't because you've got no issues in terms of what you sell. But what sort of quality bar can you put through these machines?
That's Les at Intercoat, our sponsor, by the way.
Traditional bright bar H9 tolerance is perfectly adequate for our machines. If your stock is aluminium, certain titaniums, certain stainlesses, plastics, you know, they won't be to H9 tolerance, they'll be H10 or above, but we can still accommodate them on our machines where, you know, we can adopt a JBS guidebush system in the machine. That's a pneumatic guidebush which can open and close as the diameter of the stock varies. So we've got a solution for most circumstances. On our machines where, you know, we can adopt a system in the machine. That's a pneumatic guidebush. Varies. So
When you're running one of these machines, do you have to have ground bar?
No, to be honest.
Simple?
No. That's a bit of a myth. We have systems in place where we can have compensation guidebush to allow for bar variation, but to be honest, nowadays, the way material stocks come in, they're normally pretty good. The only thing we don't want is scaled up bar.
So, I mean, bar quality is a big one, isn't it? Because, I mean, I remember going back when I have sold machines like this many years ago, and it was always a question then, you know, but don't I need ground bar? But of course, you don't.
Not anymore. Not with all the technology. Absolutely not. It's as simple as that. And they've got compensating guidebush as well, which is something we'll come to later as well.
But I like the comments made there about earlier on as well about the vibration factor, because that's the key with these machines,
Yes.
just minimising that vibration. So it's not just about the surface finish of the part; it's the wear on the tooling, it's the wear on the spindles themselves, it's the wear on the machine in general. So the more you can minimise that vibration, the better. It's like the wear on his body; the less he vibrates.
I've had no
Oh,
idea.
dear.
No. Oh, come on,
He's
please.
had a
move
lot
on.
of wear on
Anyway,
that,
you've
you
got all
can
this bar.
see.
Key to sliding heads is make. Guys, come on now. We want to run 24/7, not with you two, of course, but you want to load that bar. But if you've got a 40mm bar, for example, or even an 8mm bar, you can't just put 5 or 6 in there. So there's different systems.
The other option would be a series of shelves that the bars would be loaded on, and then they would be lifted and loaded in. There would be a pump truck option where the bars could be brought in and put onto the floor, and the bar feed would then have a series of lifting cams that would lift it up. Or alternately, we could go to the full bundle so that the fork truck could simply unload it from the lorry, put it into a bundle, cut the straps, and we could have up to 2 tons of bar in front of the bar feed to be loaded in.
So there you have it. The first part of a sliding head machine is actually the bar feeder. There you have it.
Okay, well, you then have to have a look at the headstock. Now, this is an integral part of the machine as it's moving, hence the machine being called a slider. So let's take a look at a sliding headstock. And integral to that sliding headstock is the guide bush. Let's discuss guide bush, gents, because some of us haven't always known what that is. So, Tornos sliding head machine. What's this guide bush and non-guide bush?
It would be interesting to know how many people do know the difference between a non-guide bush and a guide bush. But for those that don't, we'll explain it. Simply, a guide bush is where, actually, do you know, I don't know the answer to that. I know.
Oh my God!
I'm thinking I don't know.
I roughly know, but I don't know well enough because I could make an arse out of myself. But just ask me about it again and I'll skip over it. Don't worry.
That's hilarious.
Okay.
See, that is a classic example of skilled engineers. No, I know, Paul, I am talking about here. But you ask some questions and they're like, well, I actually don't know. So that's why we're sitting here today, because we're learning all about it. So you've got your sliding headstock. Basically, it's just a headstock that's sliding. It's in the name. But then you've got your guide bush, which is, you can equate it really to a steady and a fixed head machine. It is that simple. It sounds complicated. Well, does it sound complicated? We just don't know what it is. So that's why we're here. So what I did learn is there's actually 4 types of guide bush.
Star over the years have adopted 4 types of guide bush.
Yep.
There's the traditional static guide bush, which we don't see in Europe, but it's still popular in Japan.
But that's not actually rotating. That's,
No,
when you say static, there's a clue
it
in
is
there.
static.
Right.
The rotary guide bush, which is what we normally adopt and have done for the last 25 years. Then there's 2 other systems. There's the JBS system, which is a pneumatic compensating guide bush.
Okay.
And we also have what we call a rotary magic guide bush, which is a mechanical compensating guide bush. Most of our machines go out with the rotary guide bush,
Yep.
the standard guide bush housing, and about 20 to 30% of our machines have the JBS system.
So again, you've got your guide bush, you've got your guide bush housing. You need to change it over. As Alex said, different types. The main ones are rotary, just in there. The JBS is compensating for bar and bar quality. It is as simple as that. It really is.
So if you've got a hex bar, it's obviously got to be the rotary, isn't it? Because
You know what, Paul? That I don't know. So if you could put your comments and answers on the channel, that would be great. But I'm assuming I would assume it is a rotary one. That's why we're here, to ask questions and learn more. But because with the guide bush and the bars being pushed through, the tool is right next to the guide bush, and that's part of the benefit of the slider is you can get a bigger depth of cut and it's more rigid.
it's the security of the process, isn't it? If you imagine on a fixed head lathe and you've got a bar that's extended 30, 40, 50, 100 millimeters, and you've got a tool at the end of it, and you're moving towards the chuck. When it's at its furthest point, it's nowhere near as secure as if it.
We're getting deflection, and we've actually got a little video example showcasing that later. So I don't. Yeah, you are speaking too soon. Lucky.
Shows he knows what he's talking about.
Absolutely. Well, in fact, that's the next thing here. So it's what you're going to get is less deflection. And there's actually a mathematical equation, thank you very much, about how this works. So you push it out, say it's 2 inches out. In fact, let's watch a video first. Again, same, but I'm going to just, so deflection, same amount of force there, that will deflect. And then go there, and then deflect. So with deflection, there's a mathematical equation. I'm not going to go through it, because I don't know it and I don't understand it. But essentially, poking out 2 inches, bit of force, deflects 1 micron, double length, same force, it will deflect 8 microns. So it goes up in an exponential fashion. So,
but what does deflection do? What's the problem? What are you solving by using this process?
You're not going to make us an accurate part.
Well, no, I mean, if you've got a longer bar that's extended from the chuck and you're machining at a further distance, and this deflection, you're obviously going to have to slow the process down. Maybe you can't hit the material as hard. You might not get the same surface finish. You won't get the same precision. But there's also things like tool wear. You're gonna wear your tools far faster. You're gonna wear the machines. If something's deflecting, this is often overlooked. It's not just the in-cut process that's going to be affected. What about the machine? Think of the spindle at the back end that's getting that movement all the time.
All of these, and
spindle wear.
That is why you go inside it. But the next one I want to cover is diameter.
Okay, we can actually go from 3mm up to 45mm.
Wow, okay, with the 3mm though, you can cut even smaller bar.
Yes, we could go down quite comfortably and load 0.8mm bar into that machine.
Super small.
Oh yes.
Hence the sliders being made for the watchmaking
Exactly.
industry.
Small medical parts, watchmaking industry. That's where that avenue comes in.
Okay, you've also got the guide bush in there. You could take that out and go even bigger diameter.
On the bigger machines, yeah, we can go up, like I say, to 45mm.
Wow, and of course we go out to machine shops. We have seen so many incredible parts that people are making that are so tiny, it's incredible. And knowing Citizen, that's where they started really, isn't it? You know, Citizen watches, and it came from, and the sliding heads, there's that kind of correlation between the two, isn't there?
Most certainly is, and so accurate. But also, another thing is, when they were invented, it wasn't about big batch runs, it was small batch runs, so
Yeah, tiny
batches of
parts.
50, but because they needed to be so accurate for the watchmaking, they would get rid of maybe 20, 25, 45 of these components. They were still sort of 2 micron accuracy, but
Where Tornos are based in Moutier in Switzerland is right next to the Rolex plant. And of course Tornos,
Swiss movement.
Tornos making a lot of their machines installed in Switzerland are for the watchmaking
Is
industry.
that to do with Swiss movement on watches? Because you get Swiss movement, don't you, on watches?
Yeah, absolutely.
Exactly.
Yeah, I mean, you know, Tornos will sell in the Rolex factory. There'll be hundreds, probably thousands around the world of machines making parts for the watch industry. But the diameter is an interesting one because you're talking about small diameters. But what I know you like that, and I know people are interested in watches. But big diameters to me is the fascination because this is where sliding head lathes are eroding other markets. They're beginning to be able to compete with what were traditionally fixed head machines because, as we've spoken about, the volumes are less, but also the diameters of the bar that they can now cope with. Right. And when you start getting up to over 40 mil bar, there are fixed head machines. Okay, some people will say that there are different markets for them, but there's some 42 mil bar machines, 50 mil bar machines. You're starting to get close to that. So there's a big market there for companies that are making these bigger parts, even some that we see on the table that can really be accommodated on these machines. Now they're capable.
And you say about that, it's not just about the bar, it's about the complexity of the machining and the operation. But we will come to that. But one thing I want to talk about is the fact these are running guide bush, but you've got that flexibility to go non-guide bush. So basically whip it out. So that gives us a great point to go to our next video. I understand with a feeder, with a loader, with guide bush, with non-guide bush, there's 4 options there, but you're going to get different length of remnant?
Yeah, the rule is when we have a guide bush, our remnant length will be the distance between the headstock and the guide bush, plus normally one component, okay? So on a sliding head where, say, a 20mm machine, we've got 205mm of travel between the headstock and the guide bush, we'd have 205mm plus then a component as your remnant length that comes out the back. On the other style, when we go non-guide bush, okay, we can then not worry about the distance between the headstock and the guide bush because obviously the guide bush is removed. Therefore, we can have a short bar end of around about 4 inch, 3 to 4 inch max.
So they have it in a nutshell: guide bush, longer remnant; non-guide bush, shorter remnant, which is key if you've got those expensive materials. It really is. Again, it is application specific as well because it might work perfectly well with a non-guide bush, but also with a non-guide bush you get better concentricity, but you can't do your long parts. As a rule of thumb, 2.5D, so 2.5 times diameter of the bar. It's as simple
But
as
the
that.
ability to run a machine from one or the other is, again, I talk about bar diameters being important to opening up new markets. Having the option of guide and non-guide bush does exactly that
so
too.
much flexibility.
The flexibility
But
is,
then engineers are thinking, right, I've got to change from guide bush, non-guide bush, to take the guide bush out, take the housing out. Next video. You've got your guide bush, non-guide bush option. Is it easy to change over that housing and go non-guide bush?
Yeah, it is actually. It's quite simple. All we actually have to do is remove several cap heads, a drive belt, and then remove the housing. And then the beauty with hammer is the control then takes over to reset all the positions of the fixed collet.
So keeping it nice and simple. As a ballpark, I won't hold you to it. How long?
First time, not going to lie. When you're new to it, it will take around about 45 minutes, okay? But once you get quick, you're looking around about 20 to 30 minutes.
Wow, is that all?
Yeah.
Right, let's look at the working envelope. Now look into this sliding head machine. Look at all of those tools and options.
Depending on the machine model, we've got turret machines, we've got platen machines, we've got machines that have got a turret and a platen, we've got manual B-axis machines, we've got programmable B-axis machines. So there's a whole variety. We bring in different series of machines: SB, SR, SV, ST. They've all got their own attributes. 8 axes on this one. There's a Type B that's got 9 axes. That's got a fully programmable B-axis where we can do 5 axis simultaneous machining.
Right, so I'm thinking XYZ on main spindle, sub spindle.
Yep.
The
C1,
B axis.
C2 plus the B axis.
That's the B axis. But you can go even more than that on the other machines you've got.
Certain models, for sure, the ST series is probably our most advanced model. That's got 12 axes on that machine. It has. That's a 3-turret machine. Independent turret for the back spindle, 2 turrets for working on the head 1 spindle.
With these sliders, you've got your gangs, keeping that tool change time and idle time down to an absolute minimum. Why would you go a turret then? Because surely that's going to slow the process down.
Well, what we actually have is a turret and a platen on that machine. But the turret gives us more drive, more power, more flexibility. We can do gear hobbing, broaching off the turret a lot easier. But what we can also do, while the platen's in cut, we can actually index to the next tool on the turret and have it in position, therefore minimising that idle time totally to a bare minimum.
See, this is again another area of fascination when you look at sliding head lathes. By having, I talk about bridging that gap between fixed head technology and sliding head. Introducing turrets into it is again a further example of that. And I think having both of those options just means you might start to begin to get confused as to how is the best way to make the part. But that's where the skill set comes in of the people that are operating these machines. All that these guys can do is provide the most amount of flexibility, and that's of course what having both platens and turrets do.
Just adding to that, I went to a company in Wales, and oh my goodness, they love their sliding head machines, and it's just they started off with 1, 2, 3, 4, 5, 6, 7, 8, and I think it's something like 12 that they've got on their shop floor, all with different axes.
Yep, that's it.
Each one is doing something different.
So many different axes, so many different options. And I was surprised, again, in terms of having I thought it went completely against convention of having a turret in a sliding head machine, because you've got your gangs and that was it essentially. But it's not, because what you'll do is you'll use your gang, and then while that's machining, you'll index your tool on your turret, keeping the idle time down. Simple as that.
I mean, I might say some stupid things sometimes,
Absolutely.
and I've been
Always.
that's been said before when I've actually made this statement. But sliding head machine manufacturers are always looking to equip their machines in the same way other machine tool manufacturers are, with the most amount of options for people to use, because they know you take the B axis and the full 5-axis simultaneous machining. I've been to companies where they're making 5-axis parts, and you go, that would have previously had to have been done on a 5-axis machining centre, albeit a small one.
Yep.
Don't need to anymore. Can do it on this.
As long as you've got your sister tools.
On this actual machine, we have a straight platen along the top of the machine, but also on the back we have a Y-axis, Y2 on this machine, which gives us up to 8 tools, which can all be driven as well on the sub-spindle. On the sub-spindle itself, we have 2 driven tools on this machine, front facing, so it enables us to maximise more tooling on the machine tool itself.
And that ties in, you've got loads of tools there, but you've got that extra tool life because you're in a slider, and you've got your lubricant going on as well. So absolutely amazing.
But sister tooling is a critical part of lights out manufacturing. You know, there's nothing worse than coming in the morning to a machine that's sat idle for half the night because one of the tools is broken or worn.
Yep.
You know, if you can
You need to
quickly
have
move
that
over
kind of
to
backup
to another
set.
tool. Yeah, you can never have enough tools. You look on a horizontal machining centre that's running lights out, you can have up to 300 tools, and you want that, because if there is an issue, you're able to quickly move on to another tool. By having more tools on a slider, you can do that too.
Absolutely. And then you need to look at the configuration of those tools as well. The actual configuration here, you said it's a straight platen.
Yes.
But you have other options?
Yes, we actually have ones where you have, we can have a turret in there, okay, a turret style machine, which some people call hybrid, okay, between a slider and a fixed head. But also we have on the smaller machines, it's a horseshoe configuration, so it minimises transit time between tools.
But if you want to make complex parts, you are going to need multi-axes. When you're milling a job, we often think of a 5-axis simultaneous machining centre, for example. So how does this compare to that?
You have ones where you have
Yeah, clearly it depends on the machine, but that one as an example, 12 axes, it really, so straight away you're thinking, I can do some really complex parts. And it's not just your static tools, it's your driven tools. So you will be milling, you'll be drilling, you'll be tapering, boring, everything.
And there's a bit of synergy between talking about that and the tooling setup. It's all about idle time, and idle time is the enemy. And when you look at like the gang and the platen tools, you're able to go from tool to tool very quickly. So you're reducing immediately the amount of dead non-cut time. But by having more axes as well, you're able to obviously do more cutting operations at once as well as so it's all about getting that idle, that non-cut time out of the process.
Air time, dead time, idle time, all sorts of different names, as engineers love to name the same thing with different names.
That's true. Right, so I've got my machine, I've got a few jobs, I'm going to need to change bar diameter, change my tools, etc., and everything that comes with that. And I appreciate it's application specific, but let's have a look and find out about how easy this changeover is going to be.
If you're not changing the actual channel set that you've got in the bar feeder, just changing the main collet, the guide bush, obviously the sub spindle is component specific anyway. You know, you're looking at 20 minutes to 30 minutes just to change those three. If you've got to change the whole channel set in the bar feeder, that's a little bit more involved. You're looking 30 minutes towards an hour maybe to change the channel set over in the bar feeder. But the setting up time on the machines these days, the way the CNC is set up, the way we set tools, it's much improved from the old days, so that they are, comparable to fixed head machines.
Simple as that, really is. I make it sound simple, skilled engineers, but once they've done it once or twice, not a problem.
Okay, and what about like the length of components then?
Well, you know what? Another thing I learned, we talk about 2.5 times D and things like that. Sliding heads come into their own. Look at this.
It really depends on how much material you can handle the other side of the lathe, to be fair. We do bar feeders from 2 meters up to 6 meters. So theoretically, we could do a part that's 6 meters long as we can accommodate it as it exits the slider. Depends on how handle the other side of the lathe, to be fair. We do bar feeders from 2 meters up to 6 meters.
As long as the bar is, I can make you a part that long.
Right, so I could theoretically have a 3 metre long component.
Yes, indeed. 3 metres, even 4 metres if we went with a 4 metre bar feed.
But what's going to happen, because obviously this machine is not that long?
No, well what we actually do is we can rechuck at the front end so we can keep pushing the bar through. But then on the rear of the machine, our machines we actually provide with a long parts ejection system, so the parts can then feed outwards to a set length.
Again, I'm absolutely amazed. Can you make, 6 metre long parts?
6 metre long parts. I mean, I went to a company, Linkreal Precision, and he was making a part like this big, and he was saying how difficult it is because the material, it was a really heavy material as well, but he made it.
It'd be interesting to, if people are watching, how long a part are you making on a sliding head lathe?
And also complexity, because with all the tools, the axes, etc., the complexity these days is absolutely outstanding. I think the only limit to what you can make is your imagination. It really is. That's it.
The multi-spindle machines, though, I know you were going to mention those. They are something else too. I know it's away from the sliding head topic in a sense, but a multi-spindle machine where you can have, say, 6 spindles on the machine. Each spindle is making a different operation. So if you've got, let's say you've got 24. This is where I'm going to have to start computing the maths. 24 operations on a part divided by 6. I suppose that would be 4. Would that be 4?
Yeah.
I'll tell you what.
So you do 4 ops maybe on as an average on each spindle, and what happens is you balance it out. But what happens is every time you finish a machine, not one part's finished. That really is when it comes to mass production.
Yeah.
Although some will say that now multi-spindles are very easy to set as well, like sliding heads, so you can do lower volumes.
Price-wise, though, you're looking at a roll. I mean, the sliders are obviously very good machines, but you're looking Rolls-Royce prices as opposed to an Audi.
Ah, okay. Wouldn't mind both. Right, okay, so I've got all this technology, but what cutting strategies can I undertake?
Depending on the model,
Yep.
if we've got an opposing turrets or an opposing platen, we can do balance turning, pinch milling, differential milling, those types of functions for sure.
But can you get multiple faces in cut at one time?
Yeah, on some of our machines we can actually have balance milling, balance turning. We can actually have where we drill in the centre of the job and turn the diameter at the same time. So there's a lot of flexibility inside the machines that we have on availability from Hanwha.
It never ceases to amaze me. I see in the machining envelopes when all the gangs, platens, it's like almost like a ballet coming together. It really is. And I know a lot about that.
I don't think you'd have gone to the ballet. I would love to see you ballet dancing.
I think you're a bit of a wrong in there, actually. That's something you want to say. But it never...
Yeah, more like belly dancing.
In our area, we've just heard belly dancing as well. How rude. I'm not happy about this. If you'd like to put any comments about how rude this lot are, I'd be happy to hear it. But it never ceases to amaze me. All these, the axes and the turrets are just moving around at the blink of an eye. But then you've also got the next level on. Yes, it could be 2 faces or 3 faces in cut, which is your superimposed, let me get this right, your superimposed or your superposition machining.
Superposition mode, yes. We do on certain models, again, where we've got an independent Z3 axis, so we can be using Z1 on the upper turret, if you like, machining a certain feature. The bottom turret can be moving in conjunction with Z1, but with its own Z3 axis, machining a different feature on the bottom turret. So it can get very efficient, multi-features machined at the same time.
There, Alex said, very efficient, multi-features at one time, but in my ballet-based brain, I'm thinking, how easy is it to program? You mentioned about pinch milling, pinch turning, multiple facing cut. Easy to program?
Very, very easy. It's only 1 G code.
Oh, simple as that?
Hanwha have made it extremely easy.
Colin Thompson said there about the Hanwha machine, but it's the same with the Star and the Citizens, of course.
But there's also more brands out there. Sorry, I got a bit excited there. But,
yeah.
we know of only 3-4 brands here in the UK, but there's so many other sliding head brands that we don't talk about.
The software is a massive part. I mean, Star talk about their NC Assist software, which we know a lot of their users use, which is a template-driven piece of software which helps you create programs quickly. So some of these cycles you look at and you think, how on earth am I going to be able to put that together? But with software like that, it makes it very simple, which works in harmony really with the machine being easy to set and the guidebush, non-guidebush tooling changes.
You know about
quickly.
guidebush, non-guidebush?
All of this stuff is geared now towards quick changeovers, so those batch volumes can come down.
Be reduced.
I just want to pick you up on one point. You talk about pinch milling. The only pinching you know about is what you do in the top shelf of a newsagent's on a weekend.
Unbelievable. That's so 1980.
Yeah.
That conviction has now been quashed. So
Yeah,
moving along swiftly, Lindsay.
Oh dear. Right, okay, in the machining envelope, you tend to see lubricant in use. Is this the case all of the time?
The only thing that we need to change from one to the other is if it's got a high pressure system on, we'd have to change some solenoids on the high pressure system because they're oil or soluble specific, but the machine itself can run both, no problem.
Makes no difference.
Yeah.
Yes, we can run coolant. It's very much job dependent.
Yeah.
Okay.
Can I say application specific?
By all means, application specific. 9 times out of 10, we would run neat oil. It's what helps the machine as a general rule, all sliders. But when we have materials like plastics, peaks, even copper, for some reason standard coolants seem to run better on those materials.
Now, another part of the machining and key to profitability is process security, keeping those spindles turning. Bird's nesting is the bane of a turner's life. So how can this be reduced?
Yeah, it's basically different tools to manage the swarf during cutting. Our system obviously is the HFT. That software, it is only software, so we can retrofit it to older machines in our range, and it obviously fits all the current machines in the range as well. So
doing a similar job, but the ultimate aim is to get rid of that bird's nest, chipping the swarf, basically process security.
Turn them long strings into more manageable, smaller sort of thumbnail chips that will easily get evacuated from the machine enclosure. Well, certain aluminiums, plastics obviously, titaniums, certain stainless steels, traditionally any stringy material, so they've all got a use on those sorts of materials for sure. Easily get evacuated from the machine enclosure.
Any particular?
Well, certain aluminiums, plastics. Traditionally, any stringy.
which is a macro-driven software towards chip breaking. We've had it now, last 18 months we've been playing with it with a couple of customers in particular who do plastics and having some exceptional results with it.
When you say exceptional results, in terms of no birds nesting, process security, anything else?
Basically, the cycle times aren't as affected as much as what we had thought, but also no swarfing at all, which is a major plus.
Each company's got its own type of technology, whether it's LFV, HFT, PCR, whatever it may be, but it's all about process security.
And I think what's important about this is when I've seen it in the real world, call it, what's changed for the companies that have installed this type of software? Well, previously they may have had to run certain applications at night that they couldn't control the swarf on. Now they can run those through the night, or sorry, they may have had to run those particular jobs during the day
yes,
as opposed to at night. So they were having to adapt their production in
yes,
accordance with what the machine was capable of. That's all gone now because it's a case of, right, do you know what? I can run that job at night, that job at day. It doesn't matter because I've got the process security.
The main benefit is reducing the amount of times the operator has to intervene, basically open the door, clean away those birds' nests from the tools, from the sub-spindle maybe. So it just increases the unmanned hours you're getting out of the machine, obviously, which is also increasing the efficiency of the production.
So I can load up the bar, go home in the evening, next morning, loads of components, no issues running.
Absolutely. Full of, bins full of parts, swarf bins full of swarf, lots of profit in the bank.
There you go, Alex is pretty much reiterating what Paul has just said. But cycle times, how does it affect your cycle times? Because people, it's all about getting those cycle times down. Your cycle time can increase because the tool is not in cut as often. But what would you rather have? Maybe a cycle time going up 5%, but running 24/7?
If there was two evils, it's the lesser of them.
Absolutely, if we get that, it's definitely
Or the
the lesser
better.
of two evils.
Better of two
No, it's the
evils.
better of two evils.
Is
not
there
an
any evil going on?
No, exactly. I'll tell you what, I've got to work with these two and it's really starting to... In fact, you're causing me a problem, but there is a big problem caused by this technology.
Bird's nest.
You're a problem.
Better of two evils.
Better of two
No, it's the
evils.
better of two evils.
Is
not
there
an
any
evil?
evil going on?
No, exactly. I'll tell you what, I've got to work with these two and it's really starting to... There you go, great problem to have, it really is. But what about your materials?
Bird's nest.
You're a problem.
Definitely
Or the
less than
better.
two evils.
Is it like Danish iron?
Danish iron, no, it's Danish pastry, that's what we're thinking. No, Swedish iron, it's like an armadillo, so it's crunchy on the outside and soft in the middle. It's an absolute nightmare
Like
to
a
the machine.
dime bar.
No, you're a dime bar. Anyway,
Right, okay. Moving on. I now have a machine that can run for a long time, has lots of tools, lots of axes, and is super quick. Am I going to struggle to program it?
definitely
Or the
less than
better.
two evils.
Better of two
No, it's the
evils.
better of two evils. Paul. Absolute nightmare
Like
to
a
the
dime
machine.
bar.
No, you're a dime bar. Anyway,
Right, okay. Moving on. I now have a machine.
there's a lot of controls out there. So the Hanwha machines from Dugard, what are you running?
We actually run Fanuc controls and Siemens 828.
There's a lot of axes on these machines. Is it easy to do the controlling programming?
Yes, yeah, very much so. Hanwha has program assist for the Fanuc control that goes onto a laptop. But on the Siemens control, we have that on board. So it actually aids as similar to a shop turn facility.
There you have it in a nutshell. Easy to program. You've got a number of different controls out there, as you'd expect. And engineers want to stay with, they tend to stay with the same controls that they're used to using. So you've got your Fanuc, your Mitsubishi, your Siemens, but then sort of offline you've got your Alcart Wizard with Citizen, the Star one.
The NC Assist.
Absolutely.
The thing is with these programs that you use to help you program, it's not just about them making the programming easier, it's about optimizing that program too.
Yes.
So it's about, we've talked about all these things about idle time, reducing that, keeping the tools in cut, balance, machining, all of these things, these software elements are really important to, like I say, not just make it simpler, but also make it a more efficient machine.
And and part of these systems is they do that for you as well. But another thing is avoiding collision. Now, one of the guides is using Vericuts.
We've got a customer not too far away who's invested in Vericut software. He wants to sort of prove out everything from his his office at home, so we're helping him sort of work on that project with Vericut.
Another key thing is really getting your applications and your support. So a lot of people you find, they'll have a part they're making at the moment, they haven't got a slider, they'll go to whatever company that says, can you help me with this? And their applications guys will come up with a solution, and invariably they'll bring a cycle time down from 5 minutes, 10 minutes to 5 minutes, 5 minutes to 2 minutes. So really impressive stuff. And also the support afterwards, because again, these are complicated machines, but they're made very simple. But if you need some help, these guys are here to help you. And just,
I know it's a service that's offered by all the companies we talk to here. You know, if you buy one machine, it hits the deck. If you get another part come in, you can lean on them to help you program it. So
we've heard that
you don't need
so
to be,
many
you don't need
times.
to be worried about, not being able
even
to
if you've had
use that
no
machine.
sliding head experience, because we've had a lot of companies we've been out to see, never had a slider before. In fact, pattern fasteners, our friend James Beddoes, he's got a load of them now, absolutely swears by them.
Well, that's what they're there for. They're not only there to sell machines, but to give that support behind the sale of a machine. Right, so we've looked at the technology in a sliding head machine. However, let's look at some reasons why I would want one.
He's got a load of them now, absolutely swears by them.
Yeah, but that's what they're there for. They're not only there to sell machines, but to give that support behind this.
Why would I buy a slider?
Basically what we're trying to do is make parts more efficiently, quicker, less time of moving around your machine shop, less chance of error to get the part off in one piece, and also you can maximise, more importantly, your skills around your shop, because while this machine's running on some hard complex parts, your skilled labour can then go and do other parts for you.
So I can have a bank of 5-10 machines being run by one operator?
Could indeed.
Obviously there's limitations on the size of parts that we can do in terms of diameter. Length, there is no limitation. So for the correct application, it is it's a more widespread choice now.
Well, we've actually surprised ourselves just recently. We actually ran a trial in Korea. The part was taken 11 seconds and ran for 8 hours, in which we held 2 microns over the 8 hours. And the machine did not move.
Impressive stuff.
Very, very surprised us, to be honest. We were expecting 3, maybe 4 microns, but 2, that was special, very special.
So we try subbing certain parts out, but in the end, quite often we end up just buying the machine and doing it ourselves. So we can do everything in-house.
And what's the heart and behind your purchase? What is it the key is to when you're looking to buy a new machine?
It needs to be able to do the job we need. It's just a simple, if we need a turn part, we need a lathe. But then we look at the bigger picture for how many other things we can make with it so we can extend our product range.
And what are you looking at there? Sorry, I've got one more question. That's probably... Okay, so my next thing is, so what is it you're looking at there? Is in what's unique about that machine that you're looking at? So when you said
This
about...
one.
And more end users are looking at sliding head technology, which is
And
great.
taking their milling jobs off their mills and putting them through a slider.
Yeah, like I say, we do an awful lot of prismatic parts on sliding heads because it's a very effective, very efficient way of producing those parts.
that you're looking at. So when you said
This
about...
one.
Spread choice now, and more end users are looking at sliding head technology, which is
And
great.
taking their milling jobs off their mills.
An awful lot of prismatic. An awful lot of prismatic parts.
I've got a milling job at the moment. I look at cycle time, it's say 10 minutes, but invariably it's not taking into account them changing over the second op and things like that. This eliminates that essentially?
Yeah, once the machine's in there, we don't have to touch it.
Right.
Once it's in this machine, we don't have to touch the part. Therefore, we're not having to stop, start, moving it around the table, fourth axis, it's all there.
Colin, a great example of why you'd use a slider. Someone was doing a job which was taking about 5 minutes on a fixed head.
Yeah.
What happened when they ran it through the slider?
Well, we got it down to 2 minutes, 2 seconds per part, complete, deburred, coming off.
How?
just sheer way the machine's built, the way the machines are designed, and the closeness of tooling. We don't have the problems of sending a turret all the way back home to index. We can minimise that non-idle time.
Right. Okay. So basically, keep cutting as much as possible.
Oh yes, and that's where you maximise the parts. Also, we have the ability to split the job between the front and rear of the machine.
Yeah.
The
So
rear
some
package.
spindles pretty much
Yeah.
a free cut.
Yeah.
There are some parts that we've done in here in the past that used to take 5, I think one of them was 12 minutes each milling. We got it down to 5.5 minutes on a sliding head, and it's a milling part.
Yeah, that's been the sort of change, I would say, in my time at Star.
Yeah.
Much more complicated components coming through because people see the benefit of putting it on a sliding head machine because the cycle times are low compared to alternatives.
Complex parts.
Yeah, that's been the sort of change, I would say, in much more complicated components.
If you're cutting near the guide bush, I'm thinking much bigger depths of cut because you've got that rigidity.
Yeah, on some of our machines we can go up to 10mm depth of cut quite comfortably. Yeah, we rough and finish in one go, so we don't have to go back for multiple passes. On some of our machines where we have Siemens controls, we can actually have 23 kilowatt horse main spindle and sub spindle powers. So.
Wow, that's a real powerful beast there.
Yeah.
And relatively small bar as well.
Oh,
in terms
yes.
of diameter. So
Yeah.
huge cuts.
Yeah, sky's the limit when you go to those machines. So.
This machine, which starts in the morning, it runs all day. We have to throw a few bars in it every so often. But besides that, I walk past it and it's just churning away. The green light never goes off.
Key to trying to get the part off as efficient as you can is by minimising as much idle time as we can. On the controls, we actually have an optimisation where it looks at cutting down the tool paths to minimise that idle time where we can.
Okay, so I'm a great programmer, but this just takes that next level.
It takes our little errors out as well for us.
Our cycle times are reduced because our idle times on the component is a lot less. The machines themselves, they're all designed for unmanned machining. So it's part of our DNA, unmanned machining, so that's where the benefits come from.
Yeah, so I mean, a whole myriad of reasons why you should look at investing in sliding head technology. One point we haven't looked at is the machine monitoring, which is another key part. If you're running a machine unmanned overnight, you need to be able to dial in, you need to be able to check if there's an issue, you want to know what it is, you want to be able to diagnose that, and there are systems pretty much with all the providers we've talked about and more that will allow you to do that, so you can keep the machine being monitored during those unmanned hours, because if it breaks down or something happens, which I've got to say, to be fair, sliding head machines, they're so reliable in most instances. You go in shops and they just go and go and go. But what you don't want is, if there is an issue, to come in the morning and go, I didn't know about that when I could have been notified at 10 o'clock in the evening. I know you'd be on your vino and all the rest of it, so you wouldn't be able to do anything. But
don't know what you'd be doing, Paul.
10 o'clock would be the vodkas, mate.
But it's so funny because so often we hear people like Gio and people say these machines are a license to print money.
They are. Yes.
And isn't that incredible?
They are a license to print money, and it's smaller batch runs and it's much more intricate parts now. I don't know if I said it earlier. One guy was making his milled parts. They weren't even turned parts. They were just milled parts on his slider all day, every day. And easy programming, easy use. Why would you not invest in one?
Exactly. So there you have it. We have showcased the technology in a slider and why we would use one. So let's hear what people had to say about theirs.
It's a very fast machine. So we see this technology as the way to bring back manufacturing from Europe and from the Far East.
We're now machining components that, to be honest, we were probably unable to program before, so it's pushed us forward years in a very short space of time.
It's more about taking those milling jobs away from those.
Yeah, what we're trying to do is minimise transit time as well around the shop of a part. If we can make it complete, there's less chance of errors, there's less chance of anyone misloading, dropping a part. Also, we're maximising the actual capacity of our machines to gain you better profitability.
Well, I've got to say, there's been so much to take in this show, and I genuinely have learnt a lot today. So hopefully the audience have too.
Do you know the difference between guidebush and non-guidebush?
I do now.
Brilliant.
Go on then.
But there's
I'm
not enough
joking.
time to explain.
Thank you. But there's such powerful statements. Bringing back manufacturing to the UK, which is exactly what we want. It really is. And the guys at Oracle, it's pushed them forward years. So you've got people who are doing mill parts at the moment. Get them turned. How's that?
Yeah, honestly, the reviews that we've heard and I've seen, and I've got case studies, people with sliding head machines, and they go on and they buy another,
Yeah.
and it just continues.
And you know what the only limit to these machines is?
Come on, Paul.
I don't know.
Your imagination.
Your imagination. No, he hasn't learned.
That's where you're going to
anything yet.
struggle.
I haven't got one.